Numbers are often perceived as purely human inventions, abstract tools we develop to quantify, to measure, to count, and ultimately, to control our environment and understand the world around us. We use them daily, from simple arithmetic to complex scientific calculations, believing them to be a product of our unique cognitive abilities and cultural evolution. Yet, long before the advent of modern calculators, long before the formalization of algebra as a distinct mathematical discipline, ancient builders across various civilizations were already embedding profound mathematical principles into their creations. They weren't just constructing buildings. They were carving complex equations and sophisticated numerical relationships directly into stone, creating enduring testaments to their advanced understanding. These ancient civilizations didn't merely write down their mathematical insights on perishable scrolls or tablets. Instead, they built them into the very fabric of their world, constructing monumental structures that inherently mirror the same fundamental constants and mathematical ratios that we continue to study and utilize in contemporary science and engineering. These monuments stand as silent teachers, revealing a shared, timeless knowledge. Indeed, across vast continents and spanning many centuries, from the fertile banks of the Nile River to the towering peaks of the Andes Mountains, the grand temples and majestic pyramids of diverse cultures consistently echo the same underlying mathematical principles. It's as if this profound knowledge was either universally accessible to humanity, perhaps through observation of nature, or somehow remembered and passed down through generations, transcending geographical and temporal boundaries. At Giza, on the expansive desert plateau, stands the awe-inspiring Great Pyramid, a structure built over 4,500 years ago. It is not only massive in scale, but also a marvel of engineering precision, perfectly aligned to true north with an astonishing accuracy of within 1/15th of a single degree. This level of precision speaks volumes about the advanced astronomical and surveying skills of its ancient builders. However, the pyramid's geometry holds an even deeper secret, a mathematical constant hidden in plain sight. If you take the pyramid's perimeter at its base and divide it by twice its original height, the resulting number is approximately 3.1416. This number is none other than pi, the fundamental mathematical constant representing the ratio of a circle's circumference to its diameter. This discovery reveals the ratio of a circle, pi, ingeniously encoded within a seemingly square and linear structure. It suggests that the ancient builders possessed an intimate knowledge of this constant, understanding the profound link between linear and circular forms centuries before Greek mathematicians like Archimedes formally named and extensively studied it. Their understanding was practical and embedded in their monumental architecture. Even more remarkably, the base of the Great Pyramid is said to match the curvature of the Earth itself. This alignment is so incredibly exact, so precise in its fractional representation, that modern engineers and researchers continue to debate whether such an astonishing correlation was merely a fortunate coincidence or, more profoundly, a deliberate and intentional design choice by the ancient Egyptians, hinting at an even deeper scientific understanding. Whoever meticulously planned and oversaw the construction of this magnificent edifice clearly understood not just the practicalities of construction and engineering, but also the deeper, universal language of the cosmos itself. They mastered principles of proportion, symmetry, and the intricate interplay of light and shadow, integrating these elements to create a structure that resonates with cosmic harmony and mathematical perfection. Moving to India, ancient Vedic architects meticulously followed a sophisticated system known as Vastashastra, which translates to the science of dwelling. This ancient discipline wasn't merely about aesthetics. Its intricate rules and guidelines intricately connected geometry, the subtle nuances of sound, and the overarching principles of cosmic order, aiming to create spaces that were in harmony with the universe. Magnificent temples, such as the renowned complexes at Khajuraho and Konark, were not designed arbitrarily. They were meticulously constructed using specific mathematical ratios and proportions that are explicitly found within the Sama Veda, an ancient collection of hymns primarily focused on describing musical scales and melodic structures. This suggests a profound connection between music, mathematics, and architecture. The dimensions of the main sanctum within these sacred structures often adhere to a distinct numerical pattern: 1, 2, 3, 5, 8. These are the initial numbers of the famous Fibonacci sequence, a mathematical ratio that remarkably governs not only musical harmony and aesthetic balance, but also the intricate patterns of natural growth observed throughout the biological world, from the spirals of a seashell to the branching of trees. When priests engage in their sacred chants and recitations within the meticulously designed halls of these temples, the very architecture itself is engineered to amplify specific frequencies and resonant tones. This transforms abstract mathematical principles into a tangible, auditory experience, effectively turning the inherent mathematics of the structure into a powerful, spiritual resonance that fills the sacred space. Therefore, Vedic geometry was far more than mere decorative embellishment or structural necessity. It was a living, breathing equation, a profound mathematical statement that was not just inscribed, but literally sung and embodied into the very stone of these sacred buildings, creating a harmonious bridge between the physical and the spiritual realms. Across the ocean, the Maya civilization in Mesoamerica didn't merely chart the movements of the stars with remarkable accuracy. They developed an entire numerical system intricately built around the complex cycles of time. And at the very heart of this sophisticated system, a concept that would revolutionize mathematics, was the idea of zero. Centuries before the concept of zero formally appeared and was widely adopted in the Old World, Mayan scribes were already utilizing a distinct shell symbol to represent the concept of nothingness or completion. This placeholder was absolutely crucial, as it enabled them to perform complex calculations and develop their advanced calendrical and astronomical systems, demonstrating an unparalleled intellectual leap. Their sophisticated base, 20 numerical system, which incorporated the concept of zero, allowed the Maya to meticulously track and predict lunar months, solar eclipses, and the intricate planetary motions across vast spans of time, often extending thousands of years into the past and future. This precision was vital for their agricultural and religious practices. Even their iconic calendar pyramids, such as El Castillo at Chichen Itza, are physical embodiments of their mathematical prowess. Each of the pyramid's 4 sides features 91 steps, and when you add the single top platform, the total sum is precisely 365, which is the exact number of days in a solar year. This architectural design is a clear demonstration of their advanced calendrical knowledge. Thus, every single stairway on these Mayan pyramids served as a unit of time, a physical representation of the passage of days. And as the sun moved across the sky, casting intricate shadows upon the steps, these shadows served as a constant, profound reminder that even nothingness, even the concept of zero, possesses a tangible form and a significant role in the grand cosmic order. High in the rugged and majestic Andes Mountains, the powerful Inca Empire flourished without a traditional written language as we understand it. Instead, they ingeniously recorded and transmitted vast amounts of knowledge and complex data using a unique system called quipus, which were intricate bundles of knotted cords, often dyed in various colors, each knot holding specific information. The position, type, and twist of each knot on these quipu cords encoded precise base, 10 numbers. This sophisticated system allowed the Inca to meticulously track vital information such as agricultural harvests, the deployment and size of their armies, and the collection of taxes across their vast empire, which stretched for thousands of miles across the challenging Andean terrain. In recent times, modern researchers have made fascinating discoveries, suggesting that beyond merely representing numerical data, the intricate spacing and color patterns within the quipus may also represent a form of syntax. This implies a binary code of sorts, a complex system for conveying non-numerical information, centuries before the invention of modern computers and digital data storage. Inca messengers, known as chasquis, would swiftly carry these living mathematical records, these quipus, through treacherous mountain passes and across vast distances. They were, in essence, transporting a sophisticated network of data and information, long before the very idea or concept of data as we understand it today had even been conceived or articulated by other civilizations. In ancient Greece, the philosopher Pythagoras, while experimenting with a monochord, made a groundbreaking observation. He noticed that by having the length of a vibrating string, it produced a tone exactly 1 octave higher than the original. From this simple experiment, he realized that specific mathematical ratios were the fundamental basis for creating musical harmony and pleasing sounds. These same harmonious ratios, discovered by Pythagoras, are not only found in music, but also appear consistently in the architectural designs of Greek temples, the acoustic layouts of their amphitheaters, and even in the meticulous planning of their ancient cities. For instance, at the sacred site of Delphi, the entire layout follows a precise root 2 triangle, which is the very same geometric proportion that governs how light is refracted and shaped when it passes through prisms. Thus, Greek architecture, their profound understanding of sound, and their philosophical inquiries were all deeply interconnected by one overarching belief: that number, in its purest and most fundamental form, is the sacred language of the divine. It was seen as the underlying order that structured both the cosmos and human creations, revealing a universal truth. Centuries later, medieval Masons, the master builders of Europe, inherited and continued this ancient mathematical language. The magnificent Gothic cathedrals, such as the iconic Chartres Cathedral in France, do not merely rise towards the heavens. Their entire structure is meticulously designed and built upon principles of perfect pentagonal geometry, a testament to their sophisticated mathematical knowledge. Within these soaring cathedrals, their breathtaking stained glass windows are not just artistic masterpieces. Their intricate designs often trace the divine proportions of the golden ratio. As sunlight streams through these vibrant panels, it is guided and filtered into sacred proportions, illuminating the interior with a light that is both aesthetically beautiful and mathematically harmonious, creating a truly transcendent experience. Modern engineers, utilizing advanced scanning technologies to analyze the ancient arches and structural elements of these Gothic cathedrals, have made a remarkable discovery. They found consistently recurring numerical patterns and ratios within the architecture, ratios that are identical to the harmonic scales and intervals used in music. This reveals a profound, intentional connection between sound and structure. Therefore, each ethereal beam of light that pierces through the stained glass, and each resonant note that emanates from a grand organ pipe within these cathedrals, is not an isolated phenomenon. Instead, both are integral parts of the same unseen, underlying mathematical formula, a universal principle that unites light, sound, and structure into a single, harmonious expression of divine order. Consider the evidence, the constant pi embedded in the Great Pyramid of Egypt. The golden ratio, phi, meticulously applied in the temples of Greece and India. The sophisticated base, 10 numerical chords of the Incan quipus in Peru, and the revolutionary concept of zero, independently developed in Mesoamerica by the Maya. These are not isolated incidents. These examples demonstrate that across vastly different continents and cultures, the same fundamental mathematical equations and constants repeatedly appear. Long before extensive trade routes or global communication networks connected these disparate civilizations, these identical mathematical principles emerged, suggesting they were not merely invented, but rather rediscovered, as if inherent to the fabric of reality itself. Perhaps, then, mathematics was not solely a creation of human intellect. Perhaps it was something far more profound, a universal code, an inherent language already written into the very structure of nature and the cosmos itself. It was merely glimpsed and understood by those ancient civilizations who possessed the wisdom and insight to truly listen to the subtle whispers of the universe. Every ancient monument that still stands today continues to whisper that profound code to us. The precise angles, the intricate play of shadows, the subtle vibrations within their structures, all these elements repeat a timeless truth that modern science relentlessly continues to chase. This truth reveals that an inherent order exists beneath what often appears to be chaos, and that numbers, in their fundamental essence, are the very heartbeat of this universal order. This has been an exploration into the hidden geometry of ancient civilizations, revealing the profound mathematical insights of our ancestors. This is Truth in the Shadows. Subscribe for more fascinating journeys into the mysteries of our world history and science.